Thank you very much. So our next presentation is from the Civil Engineering Department, and it's titled The Rachel Carson High School, a Net Zero Carbon Design Build Project. Sponsored by Clark Construction, this project is about creating a school campus in Southern California that produces net zero carbon emissions. The team had the opportunity to work on the entire project life cycle. This involved a thorough understanding of geotechnical and structural design, as well as construction engineering and management. I will now invite the civil engineering team to share their presentation, please.
Hi, sorry. So we're Evergreen United, and we're extremely excited to be representing the Civil Engineering Department. We will be presenting our project of a design build net zero carbon school project called Rachel Carson High School. So starting off, I would like to be introducing my team. I'm the project executive, Gina Din, and I would say that I'm extremely proud to be the leader of an amazing group of individuals. And so, Grant?
Hi everyone, my name is Grant Hahn. I'm the head of sustainability.
Hi everyone, I'm Eric Bocastro, Structural Project Manager.
Hi guys, I'm Anja Gonzalez, the Construction Assistant Project Manager.
We also have our team here today with us, Evan Belassa, Assistant Structural Project Manager, and then Vanessa De Castro, Construction Project Manager, Martin Avila, Superintendent, Jocelyn Velasquez, Structural Engineer, George Cisneros, BIM Expert, Edric Garcia, Lead Estimator, Brian Cipriano, Project Engineer, Geotech, and lastly, Raul, Scheduler. So, for our project, we have demonstrated many multiple sub-disciplines because civil engineering is way more than we assume. We have included structural, construction, geotech, architectural, environmental, and land development. So, this is our agenda. We'll be having a scope, design, sustainability, and then construction. So, what is this project? Well, for us, it is a request for proposal provided by Clark Construction, who acts as the owner. So now we're trying to bid for this project. And this project is a design build, net zero carbon, LEED Platinum high school campus located in Irvine, as shown on the image above. And so this provided many constraints because we're bidding against another team. And these constraints included a budget of $100 million and also a 1,000 student body, as well as school amenities we had to provide. And so, why design build? Why is this so important to us? And why does this make this project so special? Well, design build is not the traditional method. It's where we bid for architectural, structural, and construction. And so because of that, we have to work interconnectedly for any changes to occur. And also it saves time as well as saves costs. But this provides a challenge of effective teamwork, which I believe my team has done successfully. And so, moving on to Grant.
All right, thank you very much. So obviously one of the most important objectives of this project is to ensure that our campus is actually net zero carbon. So I'm actually going to briefly go over net zero carbon as a concept in infrastructure. So there's two main things that we evaluate, materials and energy. So we assume that all the materials in a given building actually emits a certain amount of carbon dioxide into the atmosphere. And in order to offset those emissions, there needs to be on-site renewable energy production that exceeds energy consumption from the power grid, resulting in what's called, resulting in what's called a net negative energy usage. You can see at the bottom of the screen there. This usage results in a certain avoidance of power grid usage, and therefore an avoidance of carbon emissions that are associated with that process. So we take whatever emissions we avoid from our energy production, and then we use that to offset the emissions from the materials that we assumed earlier, resulting in net zero carbon performance. I'm gonna hand it back to Gina now.
So, how did this project happen? Well, of course, we have to have a design. So we went through many iterations. We went through sketches of a hexagonal design, a stack design, a mustache design, and because of that, we were like, is this feasible? Is this feasible for structural? Is this feasible for construction? And we communicated as a team, no, it's not. And so we went through many iterations, many layouts to fulfill what the owner wanted, which was effective layout, like effective usage of the site. For example, we have 6.42 acres, and we have about 100 classrooms, different types from auto shop and art supplies, and much more. And so we wanted to make sure that we as a team were really confident in our design. And we also went into looking into the Irvine School standards for classroom sizing as well as parking requirements. And then lastly, we were able to finally reach our final layout as shown here. So now I'll be talking further about this. So we have a classroom building, we have a lab building, and a gymnasium building. For the classroom building, it is an L-shaped structure, and it has a huge opening, which is a courtyard area to allow natural lighting throughout the entire structure. But also, it's just really a nice recreational area. And we also have a nice green roof step terrace that also collects water. And we have separated the lab structure from the classroom building because we believe it provides for a higher chemical hazard. And so fire trucks can easily access that from the parking. And we also have a gymnasium. This gymnasium is unique because it has huge spans. And so we had a challenge of that. And so because of that, we created a structural design. But also it has an architectural feature, which I'll be elaborating on, which we label as the mustache. So this feature has provided many challenges for our team, but it has become our focal point. It is basically a stepped terrace canopy shading. And so this allows easy access to the second floor where the games are occurred and which were required by our proposal. It also allows for easy exit routes for our students. And moving off to Grant.
All right, so we took our architectural models and we imported them into Lumion, which is a 3D architectural rendering software. And we're actually gonna take you on a little tour, a little walkthrough of Rachel Carson High School that was built using Lumion. So starting outside here, that building to your right with the green stripes, that is the L-shaped classroom building that we showed a little bit earlier. And then to the left there is the lab building. And we're gonna enter the classroom building here, just an example of one of the hallways. This is a particularly nice area because it has direct access to that courtyard area, sort of that hole punch right in the middle of the classroom that we saw earlier. And large windows just to keep everything open. And then we're gonna actually get a nice look at the courtyard here in just a second. And again, just a nice open area for students to relax or study. This is the gymnasium, the main gymnasium. So the owner really emphasized natural sunlighting into the gym. So again, we have those pretty much floor to ceiling glass curtain walls allowing the sunlight into the gym. Here is the science laboratory. We're gonna go through the first floor of the lab. Again, very large glass curtain walls to keep things nice and bright. And just another look at one of the hallways inside the lab here. So we're going to leave the lab and actually head right back outside to the green terrace area right in front of the classroom. Again, another great area for students to hang out or relax. If you want more videos or photos from Lumion, there's more on our website, which we'll show soon. I'm going to head off to Eric.
Okay, so how did we approach structural design? So we can't really design anything until we have a framing layout for the 3 different buildings. And so to do that, we worked with our wonderful architect Gina here to find a layout that doesn't just satisfy building codes for things like egress routes and fire safety and classroom sizes, but that's also simple and structurally efficient. And we worked with the whole construction team to make sure that the building materials we use satisfy the budget and the construction schedule and ultimately the goals of sustainability. I would love to say that we just nailed this design instantly and moved on with our lives, but the reality is that we just changed this framing layout many, many, many times, and we also changed the materials from really interesting low-carbon concrete to stick frame to mass timber. But every change was really in the spirit of trying to produce the best design that we could in the limited time that we have. And I think a really positive thing that came out of all the stress and the time demands of constant changes is that it really forced us to refine our approach and the tools that we use for design. Okay, so once we have a framing layout, we're in a really good position, but a very humbling position as students because, while we really are fortunate to have some larger group projects in this school, the majority of the problems we solve are just considering one little member at a time, and I'm not sure what happened to the screen. Oh, it just died? Well, oh, that's still going, good, good. Okay, so, while we are fortunate to have some larger group projects, you know, we're considering a single member at a time most of the time, and all of a sudden we have hundreds of beams and columns with hundreds of different loading conditions, and we're not just trying to design the members to handle the forces on them, but we're trying to make decisions about which members should fail before others and why and in what way. So it's really intimidating. So to make sense of all this, we created models within SAP 2000 to assess the stresses within all the individual members, and we did really most of the design calculations by hand or with MapleFlow. You can see that on the left there. And we also use SAP to make sure that during a serious earthquake event that lateral deflections would be well within allowable limits. So about the materials, so the buildings are substantially massed timber. It's a really beautiful material. You can have these exposed glulam beams and columns and cross-laminated timber panels. And it's very quiet during construction. As you can imagine, we pulled quite a lot from the timber design course here, but the reality is also we have these concrete footings, we have steel members in all the different buildings. So we pulled from the different design courses and got experience with all three of those materials. And so now, Evan, Jocelyn, and myself and Gino, we're all involved with structural design, but we were really lucky to have George, who has a lot of experience with BIM, and he's the one that really took the structural designs and produced the drawings so that construction could begin. And so now I'm going to hand it off to Angel to talk about the constructability.
Okay, so in terms of constructability review, our team created a constructability checklist, which required a close collaboration between our design and construction team, emphasizing the design-build aspect of our project. In this early stage, we discussed and reviewed the construction process to ensure that the design is feasible and buildable. Once we start the construction process of the 3 buildings, so by integrating the constructability review in our design process early on, the design and construction disputes are reduced, and as a result, project delivery was more secure and cohesive. So for example, a detail of the design that we were able to point out was in relation to the gymnasium building. So the design of the gym that we noticed were the length of the timber beams, as shown on the highlighted part of the beam schedule. So for easier mobility, we decided to split it into sections. And by doing so, it saves us time and lessens the cost of acquiring special trucks for transportation. Now I'll give it back to you for sustainability.
All right, thank you very much. So one of the most important challenges for our team was to really measure the environmental impact of the campus. So we used a very powerful software called SEMA Pro, which essentially generates environmental data like carbon emissions data for a large database of building materials and processes. So we actually compiled all of our analysis of the data for our materials, our energy production, and our energy usage, and then put them into what's called an LCA report, or a life cycle assessment report. And in this report, one of the main conclusions that we came to was that our on-site solar array is actually creating enough energy to properly offset the emissions from the materials, helping us to achieve net zero carbon. In addition, one of the owner's constraints was to achieve a minimum of LEED Gold certification. So we actually constructed LEED credit trackers, so we're able to monitor and update our certification level as the design changed in real time, which helped us to achieve that baseline score. Just some figures for our site. Our solar array uses 400-watt panels, a little under 6,200 panels in total, so quite a significant array on site. We also did some research for our campus, and we found a water treatment plant less than a mile away. So we actually have a non-potable piping system that redirects gray water from the campus to the plant to be sanitized, recycled, and then reused later. In addition, we were required in the RFP to produce what's called an ATC, or alternative technical concept. It's essentially an alternate building system that's proposed to the owner that either equals or betters the baseline building systems outlined in the RFP. So we decided to implement what's called a geothermal heating and cooling system that takes advantage of naturally occurring heat underneath the Earth's surface. And we actually learned that the combination between geothermal and our solar array is actually extremely powerful in terms of energy savings and therefore carbon savings, which really allowed our certification to increase to LEED Platinum. And hand it right back to Angel.
So throughout the construction process, our team was exposed to and learned a variety of softwares that are heavily used in the industry today, such as Bluebeam, Primavera P6, and Synchro. Also, to form a more cohesive project, the construction team worked closely with the design team, which helped minimize safety errors, meet project deadline, and keep the cost as low as possible. So in the early stage of construction, our team formed a risk register. This register discusses the potential risk that's related to the project and how to mitigate and manage them. So for example, procurement of we have for this project. So to mitigate that, we ordered the materials ahead of time to prevent any delays. Next, I'll be discussing about the site logistic of our project. Our design consisted of 3 mass buildings in a tight area that's adjacent to business buildings and offices. So as a result, we must ensure that the construction sequence takes into account these variables and it doesn't create conflict with the logistics. In order to avoid this, we subdivided our buildings into segments, which is shown on the left side to phase out the process. Then for considering the sequencing of we generated the project schedule. The total duration of the project is 25 months. In order to effectively manage the complexity of our project, a detailed schedule consisting of over 600 activities was crafted utilizing P6. We have regular updates to ensure alignment with the architectural and structural design, as well as to monitor project advancements. However, in cases where delays were unforeseeable, we had solutions to implement to recover lost times and prevent any undue extensions to our final completion date. And by using RS means to obtain most of our prices for our materials, labors, and equipment, our overall project cost is $97.5 million, which meets the set budget of our $100 million. The rundown for the 3 buildings is specified on the right side of the screen. Finally, by using Synchro, we compiled our design, cost estimate, and schedule to form a 5D model, which is a visual representation of our construction process of our project, which is shown on the screen. Now I'll head it back off for Gina for final remarks.
Thank you. I would like to say thank you so much to our advisors, Dr. Lomiento, Dr. God, Dr. Salem, and our industry advisors, Clark Construction. And as a team, we are really, really grateful for this experience and forever we'll remember this as a team. And thank you so much. And I would like to end with the motto, our motto, the future is evergreen.